Hi, sixth graders. We are on Unit 4 still, our fractions unit. And our topic is adding and subtracting mixed numbers. So remember, a common denominator is a denominator that is the same in two or more fractions. So for adding, subtracting, whatever operation we're doing, it means the denominator is the same. If you do not know the lowest common denominator, you can always just multiply both of the denominators together to get the same denominator. Remember, an improper fraction is when the numerator is larger than the denominator. So 11/4, 20/3. So numerator, the top number is greater than the bottom number. When we add and subtract mixed numbers, it is very much the same as adding and subtracting fractions. We want to first rewrite the fractions with the same common denominator. We add or subtract the numerators, keep the denominator the same. If the fraction is an improper fraction, we need to rewrite, but we can't forget to add the whole numbers. Then we add the whole numbers and we simplify. So let's do some for practice. Find 7 and 4/9 plus 10 and 2/9 and write in simplest form. So first of all, if we estimate, I know that we have 7 and half of 9 is 4.5, so 4/9 is really close to 7.5. And then 10 and 2/9, 2/9 is pretty closer to 0 than to half or 1, so pretty much it's just 10. So we know that it's going to be about 17.5. So that's our way of checking to make sure that when we find our actual answer that it's reasonable. So 7 and 4/9 plus 10 and 2/9. We add the whole numbers together, which is 17. We add our numerators, which is 6. Keep the denominator the same, and then simplify. I know 6 and 9 can both be divided by 3, so then we have 17 and 2/3, which, yes, is pretty close to 17 and 1/2. You try a couple on your own. If they're different denominators, remember that you need to change them so they have the common denominator. So 6 and 1/8 plus 2 and 5/8. 6 plus 2 is 8. 1 plus 5 is 6. Keep the 8. So we would have 8, and they can both be divided by 2. So 8 and 3/4. The most important thing is to not forget about your whole numbers being added. And then we have 5 and 1/5 plus 2 and 3/10. So I'm going to change my fifths to tenths, so I know that I can multiply both of the 1 and the 5 by 2, because then that will make it tenths. So I'm going to rewrite before I try to do this in my head. So 5 and 2/10 plus 2 and 3/10 would equal 7 and 5/10, which is 7 and 1/2. And then 1 and 5/9 plus 4 and 1/6. So I know that 9 and 6 can both go into 36. I know that they both can go into 54, but I'm going to do 36 since that's my least common multiply. Actually, I know they can both go into 18, so we could do 18, we could do 36, we could do 54. 18 is the least common multiple, so we're going to do that. So 9 times 2 gets me to 18, which means up here I have to do times 2. And then 6 times 3 gets me to 18, so then I have to do times 3 up here. So let's rewrite it before we do anything. 1 and 10/18 plus 4 and 3/18 equals 5 and 13/18. Subtracting mixed numbers, 8 and 5/6 minus 2 and 1/3 and then we write in simplest form. So again, 8 and 5/6 is pretty close to 9, minus 2 and 1/3. So 9 minus 2 about is going to be approximately 7. So then we have 8 and 5/6 minus 2 and 1/3. I know that my thirds can change to 6 because 3 goes into 6. So times 2 times 2. So 8 and 5/6 minus 2 and 2/6. And then we just subtract. 8 minus 2 is 6. 5 minus 2 is 3. Keep my denominator. So 6 and 1/2. You try a few on your own to get a little bit more practice. So 5 and 4/5 minus 1 and 3/10. So change this to tenths because 5 can go into 10. So 5 and 8/10 minus 1 and 3/10 would be 4 and 5/10, which is 4 and 1/2. And then 13 and 7/8 minus 9 and 3/4. So 8 and 4, I know 4 can go into 8, so multiply everything on that side by 2. 13 and 7/8 minus 9 and 6/8. So 13 minus 9 is 4, 7 minus 6 is 1, and keep the 8. 4 and 1/8. And then 3 and 2 can both go into 6, so we're going to do times 2 here, because 3 times 2 is 6, and then times 3 here, because 2 times 3 is 6. So 8 and 4/6 minus 2 and 3/6 would be 6 and 1/6. So when we subtract mixed numbers, sometimes we need to rename our mixed numbers in order to subtract them, and that's what happens when we have our fraction of our mixed number is smaller in the first mixed number than in the second mixed number. So we still have more because we have 2 and 1/3 subtracted by 1 and 2/3, but we only have a third here and we have 2/3 in the second one. So first, if we estimate 2 and 1/3 is close to 2, and then we estimate 1 and 2/3 is closer to 2, so it's gonna be close to 0, but we know that we're gonna have a little bit left over. So let's look at this. 2 and 1/3 minus 1 and 2/3. We can see I can do the 2 minus the 1 and get 1, but then if I look at my numerators, I can't do 1 minus 2. It gets me in the negatives, and that doesn't work as far as subtracting our mixed numbers. So what I'm going to do instead is I'm going to rename 2 and 1/3. So basically what 2 and 1/3 is the same as 3/3 plus 3/3 plus 1/3. It's just that this is a whole, this is a whole, and this is 1/3. So I'm going to pull out, so for 2 and 1/3, let's get a different color here. I'm going to pull out one of my wholes and make it a third, or 3/3. So I can keep 3/3 as a whole number, and then I'm going to take 3/3 and add it to my 1/3. So 2 and 1/3 is going to turn into 1 and 4/3 because I have my 1, I have my 3/3, and I have my 1/3. And then I can subtract 1 and 2/3, which now is 1 minus 1 is 0, 4 minus 2 is 2/3, so my answer is going to be 2/3. All right, here's another one where we're going to need to rename our mixed numbers and our whole numbers. So first of all, if we look at 8 minus 3 and 3/4 and we estimate, we have 8 minus about 4. So our answer is going to be around 4. So there's a couple different ways that we can solve this, and I'm going to show you both methods. So 8 minus 3/4, obviously 8 is greater than 3 and 3/4. So we know it's doable and we know we can subtract it, but I have nothing as far as fractions to take away the 3/4 from. So I need to rename my 8. So I can either change 8 into fourths, and I know that 8 times 4 is 32. So I could rewrite this as 32/4, because remember, this line means division. Our fraction bar means division. So 32/4 is the same as 8. And then let's just take that off. And then 3 3/4, I'm going to change that to an improper fraction as well. So remember, it's 4 times 3, which is 12, plus 3, which is 15, so 15/4. 32/4 minus 15/4, so 32 minus 15, 32 minus 10 is 22, and then subtract 5 more, so I would get 17/4, and then remember, an improper fraction is not in simplest form, so I need to make it a mixed number. 4 goes into 17 4 times, which is 16, and then I have 1 left over, and my denominator stays the same. 4 1/4, which is close to 4, which is what we estimated. Another way we can solve this is I can take 8, and so let's rewrite it right here. 8 minus 3 3/4, and I can take out 4/4, so basically I can make it 7 4/4, because I have 7 and 1, which is 8, but I'm just rewriting it, minus 3 3/4. 7 minus 3 is 4, 4 minus 3 is 1, and I get 4 1/4. Either way, whichever one is the most, or whichever one you feel the most comfortable using. Okay, so if we add or subtract fractions and we end up with a whole number with an improper fraction, that might happen. So I meant to have this earlier in my video and I wanted to add it in, and this is where my open slide went to. So let's say we have 4 3/4 plus 2 5/8. So I'm going to first of all find a common denominator. So I know I can change this to 8s. So I'm going to rewrite this then as 4 6/8 plus 2 5/8. So 4 plus 2 is 6. 6 plus 5 is 11. And then I keep my denominator. So I have 6 11/8. I have a mixed number with an improper fraction. I need to convert my improper fraction to a mixed number. So I have 6, and then I also have 11/8, which is going to be 1, because 8 goes into 11 once, with 3 left over, so 1 3/8. So I have 6 plus 1 3/8, which would be 7 3/8. So I just wanted you to see an example that if you end up with a whole number with an improper fraction, you need to change it to a mixed number and then add it to your whole number. All right, here's a couple with subtraction that I want you to try. I know the subtracting mixed numbers is kind of tricky, so try it and come back and check your answers with mine. So 11 2/5 minus 2 3/5. So I can already see that I can't do 2 minus 3, so I need to rename it. So I'm going to take out 5/5 from 11. So I'm going to take 1 away, and it would make it 10. And then I would have 5/5. I'm basically adding, so basically it's 10 plus 5/5 plus 2/5 is my new mixed number / fraction. So instead, I'm going to rewrite this as 10 7/5 minus 2 3/5. We already have the same denominator. 10 minus 2 is 8. 7 minus 3 is 4. Keep my denominator. I have 8 4/5. 5 and 3/8 minus 4 and 11/12. Again, I know 3/8 is less than 1/2. I know 11/12 is a lot bigger than 1/2, so I know I'm not going to be able to subtract it. So I'm going to rename it again. So I'm going to do 4, and then I'm going to take out, so it's going to be 4 and 8/8 and 3/8. So it'd be 4 and 11/8. Basically what's happening is I'm taking 1 away from my whole number, and then I'm adding the amount of the denominator to the numerator. So 4 and 11/8 minus 4 and 11/12. Now I can change it to a common denominator. So times 3 and times 2. Notice I'm doing the same thing to the top depending on what the fraction is. So 4 and 33/24 minus 4 and 22/24. 4 minus 4 is 0. 33 minus 22 is 11/24, and that's in simplest form. If the renaming from 5 and 3/8 to 4 and 11 is kind of confusing to you, you can always convert them into improper fractions. So 8 times 5 is 40 plus 3, so 43/8. And then 12 times 4, so 12, 24, 36, 48, plus 11 would be 59/12. And then you can convert them to the same denominator, and then you can subtract from there. So looking at 7 minus 1 and 1/2, so I know that I need to change 7 to halves. I know that 14 halves is the same as 7, because 14 divided by 2 is 7. And then I know that 1 and 1/2 would be, so 2 times 1 is 2, plus 1, so 3 halves. 14 minus 3 is 11 halves. 2 goes into 11 5 times with 1 left over. If I wanted to rename 7, or if I wanted to keep it as a mixed number, I could also do, and I'll write it up here, I could do 6 and 2 halves, because 6 and 2 halves would be 7, minus 1 and 1/2, so 6 minus 1 is 5, 2 minus 1 is 1.5. So we'd get the same answer. And then last one, Jermaine walked 1 5/8 miles on Saturday and 2 1/2 miles on Sunday. How many more miles did he walk on Sunday? So 2 1/2 minus 1 5/8. I know a half is smaller than 5/8, so I need to rename this. I'm going to do, let's change them to improper fractions. So 2 times 2 is 4 plus 1. So I have 5 halves minus 8 times 1 plus 5. So 13/8. And then let's convert this to get them to the same common denominator. So times 4 times 4. So 20/8 minus 13/8. So 20 minus 13 is 7/8. So he walked 7/8 more miles on Sunday. All right, that is all I have. So have a great night.